Chapter 11. Measuring the Cost of Living. To grasp the concept of the cost of living, it is crucial to understand the various price index indicators available. There are four primary indicators: the Consumer Price Index, CPI, the Producer Price Index, PPI, the Personal Consumption Expenditure Index, PCE, and the GDP deflator. First, let's examine the CPI. It measures the cost of a basket of goods and services typically bought by consumers relative to the cost of the same basket in a base year. The CPI is computed and reported by the Bureau of Labor Statistics, BLS, and is commonly used in economic studies as a key price index indicator. Next, we have the PPI. It measures the cost of a basket of goods and services bought by firms. Originally known as the Wholesale Price Index, when it was established in 1893, the PPI is also overseen by the BLS. To calculate the PPI, the BLS conducts extensive sampling of prices across nearly every mining and manufacturing industry. Changes in the PPI are often considered indicative of future changes in the CPI, as producers typically pass input cost increases onto consumers. Moving on to the PCE index, which has gained prominence and is utilized by the Federal Reserve. Unlike the CPI, the PCE index adjusts the weights of different categories of expenditures based on actual consumption patterns, whereas CPI uses fixed rates. The PCE index is computed and reported by the Bureau of Economic Analysis, BEA. The PCE is often preferred by the Federal Reserve for its inflation targeting because it accounts for changes in consumer spending habits and includes a wider area of goods and services. Finally, the GDP deflator. As discussed in Chapter 10, the GDP deflator is the ratio of nominal GDP to real GDP. Since it is derived from GDP, it reflects the prices of all goods and services produced domestically, including consumption spending, investment spending, government spending, and exports, but excluding imports. Let us now examine the various categories of goods and services typically included in the consumer basket. First, we have housing, which makes up a significant portion. This category includes shelter, fuel, and utilities. Next is transportation, covering expenses such as cars, buses, subways, and gasoline. The food and beverages category encompasses food consumed at home, dining out, and alcohol. We also consider medical care, education and communication, and recreation. Under apparel, we include clothing, footwear, and jewelry. A smaller component is the category of other goods and services, which includes items such as haircuts, cigarettes, and various festivities. Additionally, it's important to note that the concept of the Core Consumer Price Index CPI, which excludes food and energy. This is due to the fact that prices of these items exhibit significant short-term volatility. Here, let us observe the graph illustrating the trajectories of the CPI and the GDP deflator. In the graph, CPI is represented in green, while the GDP deflator is shown in red. Although both CPI and the GDP deflator are price index indicators, we see that CPI tends to overshoot compared to the GDP deflator. Let us explore the reasons behind these discrepancies. One major issue is substitution bias. This occurs because the prices of various goods and services in the basket do not change proportionately. Consumers often substitute goods that have become relatively cheaper, leading to a change in consumption behavior that CPI may not fully account for. Another problem is the introduction of new goods. CPI relies on a fixed basket of goods and services, which means it does not immediately reflect new products entering the market. For instance, new technologies like home assistant devices are not captured in the CPI until they are incorporated into the basket of goods, which can take some time. Finally, there is the issue of unmeasured quality change. The CPI does not account for changes in the quality of goods and services. While there is significant variation in the quality of products available in the market, CPI does not adjust for these quality differences, which can lead to inaccuracies in reflecting true changes in the cost of living. Please note that a perfect measure of the cost of living index should decrease when new, better goods are introduced to the market, as these improvements can lower overall costs and enhance consumer welfare. Defining the procedure for calculating the price index. For clarity, we will focus on the Consumer Price Index, CPI, as it is commonly used in professional studies. The CPI is calculated as the ratio of the cost of the basket of goods in the current year to the cost of the same basket in the base year, multiplied by 100. Once you have the CPI, you can use it to calculate the inflation rate. The inflation rate represents the percentage change in the price index from the preceding period. To compute the inflation rate, take the CPI of year 2 minus the CPI of year 1 and divide the result by the CPI of year 1 and then multiply by 100. Additionally, understanding the procedure for defining the price index allows us to calculate the dollar value across different time periods. For example, the value of a dollar in year 2 can be calculated by taking the value of dollar in year 1 and multiplying it by the ratio of the price level in year 2 to the price level in year 1. Please note that price level and price index are used interchangeably in this context. Let us now undertake an exercise to compute the inflation rate. Consider a basket consisting of 4 hot dogs and 2 hamburgers. Prices for these goods are provided for 3 different years, with 2022 serving as the base year. To begin, calculate the cost of the basket. For year 2022, multiply the price of a hot dog $1 by its quantity 4 and add the price of a hamburger $2 multiplied by its quantity 2. This yields a total cost of $8. For year 2023, use the updated prices. Hot dog $2 times 4 plus hamburger $3 times 2, which results in a total of $14. For year 2024, calculate using the prices of hot dog $3 times 4 and hamburger $4 times 2, giving a total of $20. It is important to note that the quantities of goods in the basket remain constant at 4 hot dogs and 2 hamburgers. Next, compute the CPI. For year 2022, the CPI is calculated as the cost of the basket in 2022, $8 divided by the cost of the basket in the base year, also $8, multiplied by 100, resulting in a CPI of 100. For year 2023, the CPI is computed as the cost of the basket in 2023, $14 divided by the cost of the basket in 2022, $8, multiplied by 100, which gives a CPI of 175. For year 2024, the CPI is the cost of the basket in 2024, $20 divided by the cost of the basket in 2022, $8 multiplied by 100, resulting in a CPI of 250. Remember that 2022 is the base year. Finally, calculate the inflation rate. The inflation rate represents the percentage change in CPI from the previous year. For year 2022, the inflation rate is 0%, as it is compared to itself. For year 2023, the inflation rate is 175 minus 100 divided by 100 times 100%, which results in 75%. For year 2024, the inflation rate is 250 minus 175 divided by 175 times 100%, equating to 42.86%. Consider another exercise. John's salary in 2015 was $50,000. The government statistics indicate a CPI of 100 for 2015 and 120 for 2023. Determines John's estimated salary in 2023 if it increases proportionately to the inflation rate. To address this question, we use the formula for adjusting dollar values across different time periods. Specifically, we multiplied John's salary in 2015, $50,000, by the ratio of CPI in 2023, 120, to the CPI in 2015, 100, resulting in $60,000. Now let us turn our attention to the discussion of real and nominal interest rates. To calculate the real interest rate, subtract the inflation from the nominal interest rate. Additionally, I would like to introduce the Taylor rule in this lecture. This model is used to assess the stance of monetary policy based on interest rate policy. Examine the model equation to identify the variables involved. Of particular note is the output gap, defined as the difference between the log of real GDP and the log of real potential GDP. Another component is the inflation target, denoted as pi star, which is typically set at 2%. This target is common in many advanced economies, such as the United States, the United Kingdom, and the European Union. In contrast, emerging economies such as China and ASEAN countries often have lower inflation targets due to the trade-off between inflation and GDP growth. The graph illustrates the trajectory of nominal and real interest rates. The difference between these two rates is attributed to the inflation rate. Time to undertake the quiz. Question number 1. If a Pennsylvania gun manufacturer raises the price of rifles it sells to the U.S. Army, its price hikes will increase what? The rifles are produced locally, but they are not typical consumer goods. Therefore, their price change affects the GDP deflator, but not the CPI. The correct answer is D. Question number 2. Does an increase in the price of imported French wine affect the CPI or the GDP deflator more? Since the wine is imported, it does not impact the GDP deflator. However, as a typical consumption good purchased by consumers, it affects the CPI. Thus, the correct answer is A. The price of wine affects the CPI more. Question number 3. If the CPI is 200 for the year 1980 and 300 today, then $600 in 1980 has the same purchasing power as what today? To find this, use the formula for defining the dollar value across different times. Multiply the dollar value of 1980, $600, by the CPI of today, 300, and divide by the CPI of 1980, 200. This yields $900. Therefore, the correct answer is D. Question number 4. You deposit $2,000 in a savings account and a year later you have $2,100. Meanwhile, the CPI rises from 200 to 204. In this case, the nominal interest rate is what percent and the real interest rate is what percent. The nominal interest rate is calculated as the percentage change in the amount 2,100 minus 2,000 divided by 2,000 times 100%, which equals 5%. To find the real interest rate, we first calculate the inflation rate, 204 minus 200 divided by 200 times 100%, which equals 2%. The real interest rate is then found by subtracting the inflation rate from the nominal interest rate, 5% minus 2%, resulting in 3%. Therefore, the answer is D, with a nominal interest rate of 5% and a real interest rate of 3%. Question number 5. Suppose the market equilibrium has an expected real interest rate of 3% and people expect inflation to be 4%. What is the nominal interest rate? If inflation turns out to be 5%, what is the real interest rate? Is it less than that expected? To find the nominal interest rate, we can add the expected real interest rate 3% to the expected inflation rate 4%, which gives a nominal interest rate of 7%. If inflation turns out to be 5%, the real interest rate is calculated by taking the nominal interest rate minus the actual inflation rate. 7% minus 5%, resulting in 2%. This real interest rate of 2% is less than the expected real interest rate of 3%. Therefore, the answer is A. Case study. Suppose that a borrower and a lender agree on the nominal interest rate to be paid on a loan. then inflation turns out to be higher than they both expected. Does the lender gain or lose from this unexpectedly high inflation? Does the borrower gain or lose? To address this, let us consider an example where the expected nominal interest rate is 7% and the expected inflation rate is 4%. Consequently, the expected real interest rate is 7% minus 4% equals to 3%. If the actual inflation rate turns out to be 5%, the actual real interest rate will be 7% minus 5% equals to 2%. In this scenario, the lender experiences a loss because the real interest rate is lower than expected, reducing the real value of the interest income received. Conversely, the borrower benefits as they repay the loan with money that has less purchasing power than initially anticipated.